Hi everybody, I'll try to make a short video discussing the prerequisites of quantum field theory. So what do you need to know previously to understand it? And in order to deal with the standard model of elementary particles, it is often being said that quantum field theory is the marriage of quantum mechanics and special relativity. So the main ingredients of the standard model are the laws of quantum mechanics, Hilbert spaces, and so forth, special relativity, and gauge symmetries. Of course, the general relativity, which deals with curved spacetime, is not so important for the understanding of interactions between elementary particles because it's orders of magnitude less important. It's weaker by a factor of 10 to the minus 36 or 40 perhaps. So usually you neglect anything related to the curved space-time aspects or to the general relativity in the standard model. Okay, but these ingredients are very important. So what you need to study before trying to understand the quantum field theory related to the standard model, of course. So you need to make to have a good understanding of quantum mechanics. So ingredients are quantum mechanics, special relativity. Here you need to have some basics of tensor calculus. So tensors, Lorentz transformations. Okay. Quantum mechanics, you need to understand Hilbert spaces, quantum dynamics, the Lagrangian and Hamiltonian formulations. And so on. Of course, it's very interesting if you have a very good understanding of classical electrodynamics. So, as an aside, you need to understand very well classical electrodynamics. Mainly written in terms of covariant notation or tensor notation for Maxwell's equations. Something like this. You need to have uh, at least an introduction to that matter, to that subject. Okay, so classical electrodynamics written in the notation of special relativity, perhaps. And of course, you need to have uh, some understanding about group theory. So it's a very important aspect. Group theory and applications to quantum mechanics, of course. Here, what is the most important kind of groups are the Lie groups. Okay, so Lie groups, the SUN groups, Poincaré group, and so on. Okay, so these are the main prerequisites in order to have a full understanding of a quantum field theory. Okay, a relativistic quantum field theory. So I'll try to recommend some books on these matters. Okay, if you try to understand quantum mechanics, you can use this book, Modern Quantum Mechanics by Sakurai. It's a very good. This is the revised edition, but there are other editions, previous editions. It's a very good book to discuss and to understand the basics of quantum mechanics. So I recommend this book, Modern Quantum Mechanics by Sakurai. Okay, so you can also try Cohen Tanuji. Um, Here, Sakurai, Cohen Tanuji. Great books to understand quantum mechanics. Of course, special relativity is usually addressed in many of the classical electrodynamics books, but there are books devoted only to special relativity and the main aspects of Lorentz transformations, tensors, and so on. So I recommend, in order to understand classical electrodynamics, this book here by John David Jackson, the Classical Electrodynamics. This is the third edition. In this edition, the author uses uh, the International System of Units, but in previous editions, there are other unit systems, but no problem. The main aspects of special relativity usually considers natural units in which you make the speed of light equals to 1 and so on. So it doesn't matter what is the edition of the book. I have the third edition. It's a very good book, and it deals with the classical electrodynamics from electrostatics, magnetostatics, boundary value problems, Maxwell's equations, and relativistic notation. It's very important to understand that in order to go deeply into quantum field theories. You need to understand a classical field, and it's very important because the most successful quantum field theory is perhaps quantum electrodynamics, which is the quantum version of the electromagnetism. So you need to understand classical electromagnetism in order to have a good understanding of quantum electrodynamics. Okay, so here I recommend Jackson, the book by John David Jackson. It doesn't matter the edition. Okay, all of them are very good references. Group theory. There are a vast literature dealing with group theory, with distinct applications and distinct approaches. I could recommend this one by Greiner and Miller, Quantum Mechanics Symmetries. Here you have a taste of the main aspects of group theory, Lie groups, and mainly applications to quantum field theories. Okay, but you also could have the group theory by Michael Tinkham and others, Volker Heine. There are many authors dealing with group theory. There are vast literature here in this subject. So I would recommend Grainer and also Tinkham. But the book by Tinkham is more directed or devoted to uses in solid state theory. Okay, so if you are trying to consider a book for studying symmetries or group theories, I recommend this one by Grainer. Okay, if you could have a look at the cover. Okay, this is a very good one. Also, if you are now going into quantum field theory, you have the knowledge of these aspects here, previous knowledge, in order to now attack the problems in quantum field theories. I could recommend the following books. References or bibliography, good recommended references. Good books in old style, old books. There are two. One is Advanced Quantum Mechanics. It is the sequence of this one here, which is Modern Quantum Mechanics. In the Advanced Quantum Mechanics, it is a book by Junjon Sakurai also, and it was written around the 60s, 1967, I guess. Okay, so it's an old book from the 60s. Some aspects of the electric theory were not well understood at the time, but it's a very good book, and I recommend this in order to understand also the history of the development in quantum field theories and modern aspects of the standard model. This is a previous understanding of how particles interact. And there are another book which is called Relativistic Quantum Mechanics by Bjorkin and Drell. A very good book also. Similar style to this one by Sakurai. Okay, around the 60s also. So these are old books. You can try them in order to understand a little bit of the history in quantum field theory. And now we can go to modern approach to quantum field theory. And I could recommend the following. So modern books. QFT books using a modern language and considering the aspects of electroweak theory, of quantum chromodynamics, and so on. And this one here, the book by Peskin and Schroeder, is a very important textbook used in many quantum field theory courses around the world. I recommend. This is a very good book. It goes from canonical quantization to path integral quantization and uh, gauge field theories. It's a complete treatment. It says here an introduction to quantum field theory, but it's a dense literature. It's a very dense book, in my opinion, and there are lots of problems and exercises. And you can try to solve them. Um, I guess it's perhaps the best book in quantum field theory, in my opinion. Of course, so Peskin and Schroeder. Intro. An introduction to quantum field theory. An introduction to quantum field theory. Peskin and Schroeder. It's a very good book. There is also the book Quantum Field Theory by Itzikson and Zuber. Notice that the majority of the books are titled Quantum Field Theory. So it's the name of the subject. So these are the titles of these books. I could also recommend a very interesting book which deals with the Lagrangian and Hamiltonian formulations for classical fields. It quantizes the photon field, the Dirac field. It uses canonical quantization, and at the end, it deals with the path integral quantization methods, which is by Greiner and Reinhardt. It is called field quantization. It's a very good book. I recommend it. If and you have lots of problems solved in this book, I highly recommend. And I need to say that um, Walter Greiner is very pedagogical, very didactical author. I like I like him very much for books. Recommended two of them here. One is for symmetries in quantum mechanics, and the other is for the study of field quantization. And you can try this one. Um, well, there is a very direct approach to quantum field theory, but in this book, you don't have problems, you don't have exercises to do. I like it very much, but if you are trying to do it uh, you are trying to study and you're trying to exercise yourself, perhaps it's not the best one, but it is very concise, it is very clear, and it is a book by Lewis Ryder. The title is Quantum Field Theory also. Okay. There are the books more introductory using canonical quantization by Mandel and Shaw. Also, the title is Quantum Field Theory. This book by Mandel and Shaw is very pedagogical. I like it very much for for an introduction to quantum field theory. Um, Perhaps it helps you in understanding many of the things in this book here. So it's a very good introductory textbook for studying quantum field theory. And there are the 3 volumes of Steven Weinberg, The Quantum Theory of Fields. In the first volume, he deals with the representations of the Lorentz or Poincare group, which leads to spin half particles, spin zero particles, and so on and so forth. It's a very clear presentation of the topic. And he deals with canonical and path integral quantization. Okay, in the first volume. In the second volume, it is devoted mainly to gauge symmetries. So Steven Weinberg, it is a series of books which cannot be forgotten here. So Steven Weinberg, he passed away this year, unfortunately. The quantum theory of fields. There are 3 volumes. If I remember correctly, the third volume is devoted to supersymmetries and that stuff. So very advanced topics here. So this is introductory to quantum field theory. This second volume deals with gauge symmetries and the electroweak theory and the standard model. And this one, I guess, is devoted to more modern speculative aspects, if I remember correctly. Okay, and of course, you can, in order to understand the functional integration and path integral quantization, I recommend this book here. It's a condensed matter field theory. This is the second edition by Alexander Outland and Ben Simmons. It's a very good book. It deals with functional integration. It's a very good textbook. There are many exercises in order uh, for you to understand, try to comprehend, and try to make yourself calculations. So, condensed matter field theory by Outland, Alexander Outland, and Ben Simmons. Just one here. Simmons. Condensed matter field theory. Okay. These are the books I could recommend if you are seriously considering to understand and to work with quantum field theory. Here, quantum field theory. Okay. Of course, if you are in an advanced topic such as renormalization, which is very important for calculations in quantum field theory, there are specific books. For instance, books by Zin Justin, which deals with the topic of renormalization and phase transitions in condensed matter, for instance. And also there are introductory books on renormalization by Macomb, for instance. Macomb, Zin Justin. So these authors, you could also try them in order to discuss renormalization topics. And let me see if I am not missing anyone. I guess not. Of course, there are very, very large number of books in quantum field theory. I enjoy very much these ones, okay, but you could also find another literature, very good books, also in quantum field theories. Of course, all of them deals with renormalization. Um, well, this one doesn't does not address the problem of renormalization because it's devoted to field quantization. Okay, but main uh, books, the most important books on quantum field theory, such as Peskin, Zuber, Mandel, and Shaw, presents distinct treatments of the problems of renormalization, and it's not different for this one here. Uh, the the Wilson program of renormalization is discussed here, for instance, and that's it. If you are trying to understand quantum field theory and take it seriously, you need to understand first quantum mechanics, special relativity, and gauge symmetries, which is a topic uh, which requires a good understanding of group theory. So, first of all, have a very good understanding of quantum mechanics, special relativity, and group theory. Of course, after that, and when you mastered the problems in quantum mechanics and using tensors, using tensor notation, and classical electrodynamics, you understand very, very well the classical electrodynamics, Maxwell's equations. It is time for you to go a step further and try to understand quantum field theory. Okay, because quantum field theory requires all of these ingredients. Of course, when studying quantum mechanics or classical electrodynamics, you will be in touch with the Lagrangian or Hamiltonian formulations of these theories. And of course, they are very important in quantum field theory. So, what is a quantum field theory? It's the quantization of a field. It is the upgrade of the status of a field, which classically it's a function of space-time to an operator depending on space-time, which has eigenvalues, which has eigenstates, and so on and so forth. Okay, so a quantum field theory describes which with certain requirements of causality and satisfying special relativity, for instance. But it's a theory of operator valued um, functions of space-time. They become operators. Okay, so um, I I hope it is useful for you to try to go and study quantum field theory. See you next time.